So here I present SafeTap. It is an application and also it is a website extension. So it its tagline goes like, your grandma shouldn't need a cybersecurity degree. So here in NYC codeQuest 2026, my team name is Polaris. It is a solo team and I am the only participant in it. My name is Dhruv Goyal. I am a second year BTech AIML student in VIT Jhansi. So the problem statement that I targeted is Cyber 01. Your grandma shouldn't need a cybersecurity degree. Scams, phishing email, fake websites and fraud calls are becoming increasingly sophisticated. Many people lack the technical knowledge needed to identify threats. Goal is here to help ordinary people recognize and avoid scams before they become victims of it. And the problems that I found that I can resolve in this problem statement is that there are millions of money loss that people face due to these phishing and online scams, and many elderly people don't know how these phishing scams are happen to them, and they don't know what is cybersecurity and how to learn it, and they are not supposed to learn it at that stage. So my solution to this problem is SafeTap. So here you can see that this is a Gmail interface, and whether you are on your Android or iOS or using any application basically, or using Gmail or any other related software on any website or any browser. So here what it actually does is that you will get an option like SafeTap here. So whenever any elder person, let's say our user is grandma, so whenever grandma click on that button, then that button will change into something like this. After some processes that will be in the background, the grandma didn't see them. So here is a score, a number which is in green color. It could be in green, it could be in yellow, it could be in red color. Green color represents the safe, yellow color is considered to be careful, and the red color is basically meant to be dangerous. And the I written over in this button is basically to check the reason why the link message mail has this score. So the score manual basically works like, if the score is between 1 to 20, then it will be considered as dangerous and get a red color, and if the score is between 21 to 60, then it will be considered to be careful and get a yellow color, and the score is above that, which is 61 to 100, then it would be considered to be safe and would have a green color. And the SafeTap will use 4 approaches, and these approaches will run together. There will be not like that the first approach will go first and then if it fails then the second approach will happen, but instead of that there would be a case that where these 4 approaches will go together. So a combined result will be shown to grandma, which is our user basically. So first approach will be link verification, second approach will be virtual system run, third approach will be security layer summon, and fourth approach will be family request acceptance. And the first approach is, as mentioned, link verification. So in step 1 what it will do is that if the link in the email or in messages is on Google's database, on any browser's database, and it is considered to be suspicious there, so then it will immediately show the result as 1, which is the least score and is considered to be most dangerous to the grandma, and other approaches will not be affected by that much still. So here it will get 1 score, and link verification approach will stop immediately. But if it surpasses, or I would say it passes the step 1, then in step 2 and step 3 and step 4, what is happening here is, let us consider it by an example. So there is a two website name, Amazon and Amazon. A normal person will think that these are same, but here in this website, the A is not actually English alphabet A, it is a Russian language character. So what it basically is to make fool of the persons, that they will think there's both the links are same, but both link are not exactly same. So what we will do here is that we will break this link letter wise, and then we will convert it to any other language, say French, and store that sequence into one variable, which is now target link letter sequence. And this website which we found on our Google's, we will find it on Google, that a famous website name which is similar to this website name, and which is basically the original website which is supposed by the user that this website is this, but actually these websites are both different. So this is the real Amazon website. So when we found this on Google, basically the safe tab will found it on Google or any other browser, then what will it do? It will break it letter wise, then convert it to another language, which is French. Then it will match these both letter sequence. If these both are same in French language, then it is supposed that these links are same. And after that, if it is not same, then obviously it is dangerous and will get a very dangerous result, which is 1. And after that, if this passes this step 4 also, then there will be step 5, where, like, think that Amazon website has their website name in English. They do not have their website name in Japanese characters for Japanese peoples. But any elder man in Japan think that there is a website which spells like Amazon, but it is written in Japanese characters, so he might think that it is the original Amazon website. So if he click on the save tab button, so then what he will get is that our save tab button will find that website in Japanese characters. If this website matches to any famous website in any other language, if it is found, then the safe score will decrease. So it will not give the very dangerous result, it will just decrease the safe score, and other approaches will contribute in the score for the final result. And for these approaches, the machine learning models will be used to find and detect which language it is, basically in which language these websites are actually. Then the second approach will be virtual system run. So what is happening here is actually so basically in this approach also we will use machine learning model, and step 1 will be like, whenever our user click on save tab, then so the second approach will be virtual system run, and in this approach also machine learning model will be used. So step 1 will be like, whenever user click on save tab, then the link in the email and the email also will be opened in a virtual system, not in the real system. It will be opened in a virtual system within the real system. So real system is not getting affected by you. So then we will name virtual system as Kriya for the simplicity to understand. So then Kriya will open it in it, those all links. Then in step 2, it will detect how many attacks did Kriya faces directly or indirectly through that link. So then it will plot it on a curve. Most likely this curve would be a random distribution curve, and then we will find the RMS of the 95% area of that curve, and on the basis of that value we will give it a score. So if that value is very high, then the score will be very low, and if the value is very low, then the score will be high. and high score is basically considered to be more safer, and the low score is basically considered to be more dangerous. And in step 4 it will give the score a color with our score manual. So why we are using 95% area here is because you can see this is full 100% area, and this is 99.7% area, and this is 95% area. So in random distribution curve it is considered to be the area which is to be considered or to be calculated for any approach, because this 2.35% and this 2.35% inclusively, which will make 4.7%, is basically outliers data. So we will do not consider it because it will make our real score or real value to be very different. So let's suppose case 1 where the link is really genuine. So what happen here is that the Kriya will not face so many attacks. So this curve will be very of less height, or will be at 0 height. So then the area will be very less, so the score will be very higher, and it is considered to be safe. And in case 2, if the link is a phishing link or any scamming link, so what is it will happen here is that the value of the area will be very higher because the curve will be of very much height. Then it will get a very low score, and it is considered to be dangerous. And in third approach, it will be security layer summon. So when grandma, which is our user, click on save tab, then if suppose she is on a call or she is in a message, and the message is in such a way, or the call is in such a way that she got emotionally or mentally convinced that she need to give her OTP or password or anything. So any link, she is not supposed to give these things because she is so elderly person. She is not supposed to give those things. So what it will do, our safe tab here, that it will summon or basically activate a security wall there to prevent or to secure password, payment method, screen sharing access, and on remote control of device, so that any scammer will not get the access of these things whenever he is on a call or through a message. And this security layer summon approach will be used on both Kriya, which is our virtual system, and on our real system also. Why on virtual system? Because in virtual system it might be a possibility that it would get hacked somehow. So still it will be safer to have a security wall on those password, payment methods, screen sharing access, and on remote control of the device, because these are the basic things which a scammer wants to hack the device. And machine learning model will be used here also to prevent different type of attacks. And the last approach will be family request exception. So here every time safe tab will be clicked by the user. So either if it is safe, considered safe, green score, then it will have no issue. But if it is in yellow or it is in red, so if it is in yellow, then what will happen there is that the link, call, message or email will be forwarded to a family member which is already being registered on the safe tab application, that whenever there will be a cyber security threat, then contact to that person. So now that person will deal with the link, call or message. If the score is be careful, which is yellow score, and if the score is dangerous, then the things are not forwarded to that family member. It is a simple message will be forwarded to that person that something, a cyber attack was about to happen but didn't happen. And there might be a possibility that family member might be busy, so there will be many family members in a priority list, that if that person didn't respond to those call messages and links which are being forwarded to him or her, then to contact other family member, then to other, like that. And there are some notes that I would like to clear here, that there might be a possibility that there would be a query in the link or any email or any message, So which when our system will scan that email, so it might surpass it, or it might help to hack that system within. But I believe that there are many technologies which prevent it, but I am not aware of those technologies now. But I am confirmly sure that there are such technologies which are present, because many organizations like cybercrime related organizations and police organizations use it. So I don't know what exactly they use, but I know there is a thing which we can use in our safe type. And the second note I would like to say is that uh, as for the simplicity and for the efficiency, our app could save those link mail messages of all contacts number, so that whenever the cyber attack from those things happen against from those same things, so it will give very efficiently the answer that it was considered dangerous that time. So please be careful, or please do not click it on it because it was dangerous that time, so it will be dangerous now also. So that's all. Thank you. That's our safe tap. One tap, stay safe. Thanks.